All right, so problem 9.3, to determine the reliability of experts who interpret lie detector tests in criminal investigations, a random sample of 280 such cases was studied. The results were, in this table, we can see the suspect's true status, either they were guilty or innocent, and the decision made by the lie detector experts guy. So either they said that they were innocent or guilty. So we're saying that the null hypothesis, HO, our HO, is that the suspect is innocent versus the alternative, our HA, which is a suspect is guilty. Then we could estimate the probability that experts who interpret lie detector tests would make a type 2 error as. All right, so let's break down what a type 2 error is and a type 1 error is and all that. So got a type 1 and a type 2. They're both bad. And they're both essentially coming to the wrong conclusion. So let's first look at what the possible outcomes could be. So either you come to the correct conclusion by saying the suspect is innocent when they are innocent. So this is correct. We'll put like correct, or let's put a big C there. Or if you say they're guilty when they are guilty, that's correct. So these two are correct decisions. That's what you want. You want to be correct. You want to be right, as everyone wants to be. Now, you can make a mistake by saying they're innocent when they're guilty, or by saying they're guilty when they're innocent. So if you remember, a type 1 is when you reject HO, when you reject the HO, null hypothesis is what I mean, reject HO, when the HO or the null hypothesis is true, when HO is correct. When HO is correct. Because it wouldn't be a mistake if you rejected it and it was, if it were not true. It's only a mistake if you reject HO when it's actually true. So you reject HO when HO is correct. You made a type 1 error. And so that would be based on what we're told here, that the suspect is innocent. If they're innocent, they're going to be here. So this is a type 1 because they're innocent, but you reject it because you made a mistake. You said they're guilty when they're not. You made a mistake. So this is a type 1 error. And then a type 2, type 2 will be this as you process elimination, but you basically fail to reject. You fail to reject HO when the alternative is true, when HA is correct. You fail to reject HO when HA is correct. A way that I like to tell people to remember, like people, my students and those that I teach, type 2 fail to. Type 2 fail to. So type 2 is when you fail to reject HO when the alternative is correct. Because again, that's the only way it would make sense for it to be wrong. So type 2 would be this, saying that they're innocent when they're actually guilty. So then the probability of a type 2 error is, now the only way you can make a type 2 error would be for this to be true. So when it's true, we have 140 times in this table that the suspect is guilty. And out of those 140 times, 15 of the times they said they're guilty. So the probability of making the type 2 error is 15 out of 140 because we only care about this column. So our answer would be what am I, 15 out of 140, C. There we go. I don't know why I blanked out there, 15 out of 140. Okay, now problem 4. A significance test allows you to reject a null hypothesis HO in favor of the alternative hypothesis HA at the 5% significance level. So alpha equals 0.05. What can you say about significance at the alpha level of 1%, at the 1% significance level? Now, here's the thing. Let's just draw like a picture because that's always helpful. Alpha, remember our alpha is if it's 0.05, we're saying that the area to the left, if we're saying that, you know, our alternative is less than in this direction, we're saying that, you know, there's 5% area here. And if we fall in this region, we're going to reject the null hypothesis. Now, the thing is, just because if we know that it falls in here, we don't know if it's going to be also less than 1%, because 1% would be much farther, like, you know, 4% farther, so to speak, farther toward the tail, like, so that 1% is left. So the only way you would reject it at the 1% significance level, if it also falls so far towards the tail that there's only 1% tail left. The thing is, you don't got any evidence, you don't got any data. How do you know, like, if you're going to do that? You really can't say that if you only know it's 5% without giving any other information. I think what they're trying to get at is that if they were to say like 10%, like, oh, you're going to reject it at the alpha, at the alpha equals 10%, where 10% is all this. If you reject it at 5%, you can also reject it at 10%, because we know 5% is less than 10%. And you can say 20%, you can reject it at. But you can't say anything about rejecting it at a value or percentage smaller than the 5%, because you don't have any more information. So you need more data, you need more information, and vice versa. You can't say that you won't reject it, that you fail to reject it. So the answer is the E.